In this, the final video, what we're going to do is talk a little bit about some of the broader concepts that you may encounter when you're looking at research in business. And in particular, we'll talk about the notion of constructs, the notion of validity, and a little bit about exploratory research. And one of the things we'll do in here is we'll do a demonstration of one particular technique, principal component analysis, but nothing in this lecture is specifically intended to be tutorial. This lecture is mainly focused on thinking about some of the broader concepts that you'll encounter as you start to look at data analysis in the program. So what are the overall objectives of this lecture? Well, to start with, we're going to have you do a survey on vacations. And unlike our other surveys, there's not going to be anything like a dependent variable in this particular survey. Rather, we'll be asking you about the likelihood that you'll do a whole bunch of different activities on a particular vacation. We'll then talk a little bit about the nature of research validity. We'll talk about principal component analysis as an example of a way that we might use to try to compress too much information into something that's a little bit more manageable and might ultimately be the basis of a theory or a conceptual scheme. Then we'll briefly talk about some other exploratory techniques. So what we're going to use as an example for the challenge of construct development is a vacation survey. And the idea of this survey is that you begin by visualizing some vacation, and then we're going to give you a series of activities that you will identify as being very likely or very unlikely to do based upon that particular vacation. And then what we're going to try to do is we're going to sort of discuss the survey as we did in the workshop, and then we'll look at an analytical tool that might be used to help us make some sense of it. Though, once again, with a limited amount of data, we cannot necessarily be convinced that this is going to be all that accurate, but rather it's an illustration of the type of thing that you might see in some of the business research that you encounter. So, just to review, the survey that everyone filled out began by asking you to visual a vacation, as we saw on the previous slide, and then identify how likely different activities were. Activities such as swimming, walking, playing golf, playing tennis, going to the theater, attending a sporting event, fine dining, playing video games, and so forth. And the first question you might ask about something like this is the degree to which such information might come in useful. And I would argue that if we could find groups of information, groups of activities that were very highly correlated, that might be useful for a marketer. For example, if you find a whole bunch of activities that are highly correlated with drinking, then if you're a beverage company, you might decide to sponsor events like that, just as an example. What's different from this survey from some of the other surveys we've had is there's no clear dependent variable. Actually, what we're really looking for is potential relationships between the 25 different activities. And obviously, this 25 activity list was not exhaustive. I could have gone on to 50 activities, but I didn't want to try your patience for the people who attended the workshop filling in the survey. What challenges does this survey present? Well, two main challenges. One, there's a lot of information included in it, and two, it isn't really clear what the direct purpose is. This is the type of information that we'll be getting lots and lots of in the future as we gather data electronically from many, many sources, but it's not clear what to do with it. And this is a challenge that companies are faced with the big data issues even today. Is there a dependent variable? Well, I think I let the cat out of that bag. No. Rather, what we're more interested in is finding relationships. How might the information be abstracted? If you start having 25 activities or 50 activities, you get so granular you can't really use it for anything. So what we're kind of looking for is patterns among activities that'll help us predict some of the things folks are doing. Finally, again, another cat let out of the bag. We'll be getting more or less of this data in the future. Absolutely, we'll be getting more because the world is doubling the amount of information stored in some ridiculously short period, like 18 months. And so more and more of this type of data will be available, even if it's not collected from surveys. So before we dive into this data, it's worth stepping back and thinking a little bit about what constitutes good research. That's going to be very important for people in the DBA program. So, what are some of the characteristics of good research? Well, one characteristic is that it's parsimonious, which is to say it uses as few constructs, concepts, and so forth as possible without using so few that you lose the value. So we want to use just enough information to capture what we're looking at and no more information. Because the more items we're thinking about, the more information that's required for the analysis, the harder it's going to be to communicate and the harder it's going to be able to do it without making errors. Second characteristic is we want the procedure for developing that research to be transparent. One of the great concerns in research today is the subjectivity of the researcher, because with the kind of toolboxes we have, if you want a particular outcome for your research, you will almost always be able to find it if you just put together the right set of tools, whether or not it's actually true. So you want to have procedures that an external observer can look at and say, yes, the procedure this person followed is consistent with what we would like. This goes right on with the notion of objectivity. You as a researcher don't want to come into your research expecting a particular outcome, because if you do, you will almost surely get it, but it may not replicate. In other words, if someone else tries to do the same research or the same type of research that you did, they may get a totally different finding. Finally, you want to demonstrate the validity of your research. And validity is a little bit more complicated a concept, and so we'll talk about that in more detail in this lecture. What do I mean when I talk about validity? Well, commonly in our research, there are 4 sources of validity that we specifically look for. The first source is reliability. And what reliability means is each time you gather the same data, you get the same results. So a good example of reliability is, does the same question placed in 2 points in the survey produce the same outcomes? And in the automobile survey of the previous video, we had 2 model cars that had exactly the same components. So if the survey was reliable, people should have given pretty much the same price for both of them. Another type of validity is internal validity. And this is really the logical consistency of the research. Is your model logically consistent with itself? Is it consistent with past research? Does it make sense? And in some respects, this is what we spend a lot of time in our papers trying to justify, why it is that the theory or model we're proposing or defending or attacking is or is not internally consistent. Another type of validity is construct validity. Very often in research we use abstract constructs as part of a theory. The question is, can we tell these constructs apart, and can we provide a basis in our research for understanding the constructs? So, for example, motivation is a construct. So when we talk about motivation, are different researchers talking about the same thing? Are there ways to consistently measure motivation? Can we tell motivation from other constructs such as variety? a great deal of effort, particularly in psychology, is spent demonstrating the psychometric properties of different constructs such as intelligence, demonstrating that they are actually real even though we can't directly measure them, and they are important and useful abstractions. Finally, we have external validity. And external validity is the degree to which the research that we conduct in our particular context is likely to generalize to other contexts. So, good research that has external validity is going to be strongly supported by real-world behaviors. So, as I mentioned, reliability is essentially the degree to which the same stimulus produces the same response every time you give it. And in the case of a survey, reliability would be the degree to which a question asked in different ways produces the same response, or asked the same way. And so in this particular example from our previous video, the P1 and the P4 cars have exactly the same configuration. So we would expect them to have exactly the same price. And in fact, in the survey that we did, I think about a third of the people responded with different prices for those two cars. So that would suggest that our measurement of price isn't very reliable because it can be affected by things like answering questions on other cars. Now, there's a test of reliability that's most commonly used, and you'll see it used a lot in research. So if you hear about a test called Cronbach's Alpha, that's a reliability test. And basically, you take responses to questions that are supposed to mean the same thing. And it could be either positive or negative, because if you negate a question, particularly if you're using a scale like a 1 to 7 scale, you want to get the opposite results for the negation of the question that you do for the positive version of the question. But at any rate, you take these similar questions that you expect to get the same response from, and what Cronbach's Alpha does is it takes a look at the degree to which the responses follow each other. It's basically a more sophisticated approach to correlation, because we would expect the same question to be highly correlated with other questions that are the same. In most cases, your construct validity is an attempt to develop abstract constructs from something like a questionnaire. And here's an example of the correlation matrix that came out of the survey that was done by the participants of the workshop. And what you see is that there are some items that are very highly correlated and some items that are hardly correlated at all. So, for example, A3 and A4 are negatively correlated. If you take a look, I'm just looking here for some very high correlations. Okay, A20 and A7 are very positively correlated. And a lot of times what you try to do is group together highly correlated and negatively correlated responses into a single variable. And what that does is it saves you, the need from asking all 7 questions or whatever the number is. It also helps give you a sense as to how people think about things. And we'll look at the actual results from our survey using a technique called principal component analysis shortly. But ultimately, the correlation matrix tends to be an important source of the constructs that we're using for analysis. So, as I mentioned, constructs tend to be abstract concepts that we believe are important even if they can't be directly measured. And one of the most important things about your constructs is you have to make the argument that they are valid. They aren't just things that you made up, or if you did make them up, you have some evidence. So, like all forms of research, the best constructs are parsimonious. You don't have too many of them. Transparent, you can show how they were created. And objective. They don't depend upon your saying, well, I'm sure the world operates this way. And if a construct has those three characteristics, then you're well on your way to getting construct validity. So if we look at parsimonious, we want to have as few constructs as possible without loss of significant information. So we don't want to say, well, 2 constructs is better than 3 constructs if 3 constructs covers most of your information, whereas you lose a lot of information only going with 2 constructs. Transparent, we like to be able to document the process by which we develop the constructs. And this is one of the reasons where if you can find a statistical technique that will give you a kind of a starting point for your constructs, then you can make the argument that it was a statistical package, not you, that decided what these constructs were. And finally, objective. And once again, the notion of using a tool to develop your constructs or using constructs that have been demonstrated in prior research are 2 ways that you can demonstrate that the constructs are not just something you made up based on your intuition, but that they're something that are either supported by the literature or come out of accepted forms of analysis. So what we're now going to do is we're just going to do some analysis of the vacation data that was entered during the workshop using a tool called principal component analysis. And I make no assertions about the usefulness of this particular tool in this particular context, but what it does is it kind of demonstrates a little bit how we might use advanced tools. And there are many tools like this in your typical statistics package like SAS to help make sense of data such as the data we gathered from the vacation analysis. So the technique I'm going to demonstrate here for the purposes of analyzing the vacation data is one called principal component analysis. And principal component analysis comes out of linear algebra, a course that I got a C in an undergraduate and have not taken since. I make no particular argument for the appropriateness of this survey. Rather, I'm just showing you the types of things that you might be able to get out of a survey such as this. And the idea is of principal component analysis is that it's possible through transformation to take n variables and transform them into n uncorrelated factors. And the key thing is uncorrelated because, as you know, when you do regression analysis, correlation between variables is can be very challenging. And each factor is basically a sum of the values of the n variables with a particular coefficient. So in a sense, each factor looks like its own regression equation. But what you can do is you can take all n of these factors, put them in a regression equation, and you'll get the same r squared, but you'll get different coefficients because instead of using the values from your survey, you're using factors instead. Now the thing about principal component analysis is that you can choose as many components as you want up to n. And a lot of times, if you just take, say, 3 or 4 components out of 25 variables, you can get very, very close to the same r squared, which is to say you don't lose much information. And then it's sort of interesting to see what the different weights on the different factors are, because sometimes what happens is variables that are highly correlated or negatively correlated tend to group together, and that tells you, by looking at the factor, you can get a sense as to what's going on. And so principal component analysis might be one way of doing a more parsimonious analysis as opposed to just using, all of your possible variables. Whether it works or not really is going to depend a lot on how many factors you need. If you need 20 out of 25 variables to get very close to the r squared, then the principal component analysis really hasn't helped you at all. On the other hand, if you can get most of the information out in 3 or 4 variables, then if those 3 or 4 variables show you some interesting stuff, that might be something that would be useful and something that you could talk about in a paper. So I'm not going to waste a lot of time on showing you the analysis, but I will just sort of step you briefly through what I did. So I took the survey and then I downloaded the survey into an Excel spreadsheet. Then I modified the survey a little bit to give me the specific headers that I needed and to give me names for each observation. The JSP package does not do principal component analysis, so I literally did a search on the web for principal component analysis and found a website that allows me to do it. Now this website can be a real pain in the neck to use, so hopefully this will come out. But what I did was I put the link to the website on the Canvas page. So if we come over here and we come down to the constructs validity, this principal component analysis, so I selected that. And this is just a public website that's basically a web calculator. So what I'm going to do now is I'll just try and reshape this web page a little bit so you can sort of see what I'm doing. So what it does is it basically allows you to do a principal component analysis. And I've got the data formatted. It's very sensitive to format, and God help you if you've got any missing variables. A program like SAS would do this obviously much better, but I will delete this, and then I will come over to my spreadsheet, and I will basically select my data here. Come down. So now I've selected all my data, Control C. Then I will come over here, I will paste that data in. Then I will scroll down a little bit here. It needs the names of every column. And here, once again, I've got the names of every column up on top. So I'm going to take this and I'm going to go all the way over. By the way, it took me about 20 attempts to deal with the missing data in the very specific format, so it's not necessarily easy. So we'll come over here. I think sometimes, so let's see, we got the names all here. I think sometimes it objects if I have an extra return at the end, so we'll put that there. And I think what I'm going to do is I'm going to ask for 4 factors, which is what I have demonstrated on the slide. I'll scroll down here, I will run the compute. And we'll see if I got an error message. Names of X columns has a hard return. Let's see, did I have a hard return at the end? Yes, I did. As I say, this thing is very sensitive, so what we'll do is we'll try that again. Let's see here. Come on. There we go. So now we've got these factor loadings, which are hopefully the ones that I copied to the slide. So what I'll now do is we'll take a look at those loadings on the slide. And what I did here, just to make it a little easier to read, is I pasted in the names of the different activities here. And then I just highlighted the factors which had the highest loadings on them. Now, in an ideal world, what you would find with these factors is you get one high loading and every other loading would be low. And a lot of them are like that, but some are not. Like this one here, 0.411 is fairly high, 0.698 is pretty high. Those two are low. Some of them, like this one, had a pretty clear loading on factor 3. This one had a really nice loading on factor 4, and so forth. So what this tells us is each factor has certain variables that particularly drive it. And their names 1, 2, 3, 4 aren't very useful. So what it's useful to do, if you're trying to develop constructs, is to try to get a sense as to what drives each factor. So we'll do that on the next page. What we did during class discussion was just to take a look at some of these factors and just, toss out some possible names. And principal component analysis might not be the best tool for identifying factors. There's another tool called factor analysis, which I'll talk about, which a lot of researchers often use. But this gives you the kind of big idea. So we look at the first factor, and all I've done is basically listed all the things that were highlighted on the previous page. It has a positive walking, communicating with nature, exercising, negative on playing cards, gambling, and golf, positive on sightseeing tour. This is obviously, suggests, unsupervised or unstructured events, walking around, communing with nature, exercising. Sightseeing tour is a little structured, I'm not sure, but basically, it's walking around, but not really competing. I don't know what we call this factor. Maybe strolling or something like that. Now we look at the second factor, and positives pretty much down the board: visit museums, sporting events, sunbathing, shopping, boating, so forth. A lot of these look like urban events, so originally I thought it was an urban sort of factor, but boating didn't necessarily fit in there. Someone in the class suggested that maybe this is a cruise, and it's true. All of these are activities that could be done on a cruise. So, if you're a marketer, you might look at all these things and think about, well, this is, this would be a good place, to advertise a dancing academy or something like that if people are getting ready to go on a cruise or something like that. I don't really know. The point is that everyone can make their own interpretation, but as long as you're transparent about your interpretation, at least people can't quibble with the fact that it came out of your numbers. Third factor, positive reading, swimming, tennis, sunbathing. Negative, skiing, fishing. Positive, video game. Negative, new activity. One of the things that struck me is that these activities are, for the most part, activities that you would do in Florida. The only one that's kind of an outlier there is fishing. There's a lot of fishing in Florida, and that's negative. But I'm thinking that maybe this would be, people whose ideal vacation is staying at home. Don't know whether that's the case or not, but, the reading and the video games were both activities that you probably do at home. And then our fourth factor, basically going to the cinema and drinking. Drinking with a very strong relationship. This just may be drinking, and we don't want to interfere with it by doing things like watching a movie. Don't know. Obviously, what I'm doing here is very subjective, and this is, one of the challenges of using a form that has not been validated. So I don't really know what type of factors would come out of this form. And this is the type of issue that you're likely to run into in your own research when you're designing your own forms. So as a consequence, if you want to do stuff that is going to be viewed as really rigorous, you always try to find somebody else's survey that's already been validated so you have some idea of what its properties are. On the other hand, what I'm doing here is kind of showing you the process of trying to make the sausage. The slides show you the process that you can use to actually create the data that I analyzed using the materials, using the spreadsheet that I gave you and so forth. And you can go through the slides if you're interested in doing that. My own feeling is that this whole process, especially given the nature of the survey, isn't worth a lot of time, so I'm not going to go over it here. But this at least shows you what I did if you're interested in reading. So what I'd like to do is basically end this video with just a very quick overview of some exploratory techniques that you might find yourself interested in using, or more likely encountering in research that you read over the course of the program. Exploratory research differs from hypothesis testing in that in hypothesis testing, what you're trying to do is find evidence for or against a given proposition, whereas in exploratory research, what you're trying to do is surface new ideas. And a very common technique that's used in exploratory research is exploratory factor analysis. And exploratory factor analysis can easily be confused with principal component analysis because the end products look kind of similar, but in a sense they're complements to each other. In principal component analysis, what you're doing is you're creating factors that you could substitute for your variables within a regression analysis, for example. Whereas in exploratory factor analysis, you start with the notion that there are specific constructs out there, and what you try to do is fit those constructs to observed variables. So whereas in factor analysis, you're creating replacements for your vectors, for your variables. In exploratory factor analysis, what you're doing is you're creating explanations for your variables. So you might say a particular variable is a consequence of motivation and enrichment and any other of these factors, and then from your variables what you would do is say, okay, enrichment is going to be these values, it's going to be these three variables are going to contribute to enrichment, each of which have the following weights. And there are all sorts of tools for visualizing factors and so forth. And factor analysis is frequently used in the process of trying to establish construct validity. If you encounter factor analysis in a paper, just go with the flow and try to get the big picture that what they're trying to do is they're trying to create underlying constructs that explain the data that has been gathered. Cluster analysis is a tool that's being increasingly used in big data, and the idea is that you have all sorts of observations, such as the observations we used in the vacation survey, and what you're trying to do is group them into related clusters. So that was a little bit of what we were kind of hoping to do with the principal component analysis. We were trying to find variables that group together. Whereas in cluster analysis, what you're trying to do is find observations that group together. And cluster analysis can be very useful when you've got situations where, say, you've got different types of customers. And we saw an example of where cluster analysis might have been useful if we had lots of observations when we did the automobile survey. Different people have different ideas of what they want in a car. For example, I have no interest in a turbo engine. A weak engine gives me all the power that I need. I don't need power, and I would pay not to have a sunroof because it looks to me like it's something that would just cause trouble in the long run. Whereas other folks feel very differently. Otherwise, there wouldn't be the turbo option. Otherwise, there wouldn't be sunroofs. And so the idea is to take all your observations and say, okay, there's a whole bunch of observations that cluster together. Grandon's a member of this cluster, and we won't try to sell them moonroofs and stuff like that. But we might try to sell them electronics because he seems like he's really excited about a good audio system or something like that. Whereas then you'll have another group of folks who are clustered around the turbo. Maybe they're the one group of people who actually want a manual transmission as opposed to an automatic transmission. And the idea is if you can identify these clusters, then you might be able to build products around them. And one of the things that has been incredibly useful in getting data for cluster analysis is the use of barcode data, because one of the things it does is it allows you to decide what things people are buying together. And so cluster analysis is every bit as subjective as the PCA analysis in terms of the names you give the clusters. And you also have to specify how you're going to determine similarity. Does similarity mean overall correlation? Does it mean correlation on specific variables? Are you looking for similarities or differences to split things apart? So there's a whole bunch of different things that you could specify. But it's a nice way of exploring the data, especially when you've got lots and lots of data, in order to develop abstract notions of your observations that you would not necessarily be able to do otherwise. So whereas principal component analysis was mainly interested in clustering variables together, cluster analysis is normally particularly interested in clustering observations together, i.e., survey responses and so forth. A technique that has gained a lot of favor in my area, MIS, also in areas like management and marketing, is something called structural equation modeling. One of the challenges of tools like regression is they really do not give you any clear indication of causality, and also they tend to depend on the actual data you've gathered. They don't really provide you much leeway for intermediate constructs that might be useful for your theory. So that in structural equation modeling, what happens is the investigator starts with a particular model that assumes a pattern of relationships and then analyzes the data, and typically a lot of data, to try to figure out how strong the linkages that are predicted are between the various elements of the model. And the model includes values that are strictly a result of data such as survey responses, but also latent variables. These are the constructs the intermediate constructs that you think might be present. It depends on a lot of data being available. Structural equation modeling you cannot do with small data sets. And what it does is it allows you to link your data to theory, and it also gives you probably a better sense of possible causality between relationships than your traditional regression analysis. Having said that, there are lots of people, myself included, who think that a lot of this is essentially voodoo, and are a little reluctant to put too much faith in it because it does depend upon a lot of assumptions. Particularly, it assumes that you don't have lots of interactions between the different variables that you're dealing with. And in my view, a lot of today's data has that interaction, so we can't just assume it away. But nevertheless, you are likely to see it. And I'll give you an example of what this might look at. So here's an example of a structural equation model that came out of Anol Bhattacharjy's research. He teaches research methods in our program. And what I want to illustrate here is simply how you might interpret this. I am not going to talk about how you actually managed to get to this model. And the first thing I would say is whenever you look at something like this, look for p-values. And what you see here is down here in the footnotes, footnote of A means p less than 0.001, a footnote of B indicates p less than 0.01. So we can look for superscripts here to determine significance. Now, what this model basically says is that in the adoption of an information system, because what he's looking at specifically is continuation of use of an information system. Because one of the things we find is a lot of people will start using an information system and then stop. Perceived usefulness contributes in two ways. One, it contributes directly to our intention to continue. That's at a high p-value. And it also contributes to our satisfaction at a slightly lower p-value. But nevertheless, it contributes to our intention to use in two ways. Confirmation, essentially evidence that what we're doing actually makes things useful, is contributes to perceived usefulness. In other words, if we're getting confirmation that the system's useful, that contributes to perceived usefulness in a big way, and it also contributes to satisfaction, both of those at a high significance. Satisfaction contributes to our intention to continue to use, and perceived usefulness contributes directly to our intention to continue using. And satisfaction would be an example of a latent variable. We don't necessarily have a direct measure of satisfaction. So as a consequence, this is the overall model. As I say, I have no interest in explaining how the sausage was made, but if you see a diagram like this, what you're basically going to do is look at the arrows, look at the significances, and you can sort of get a sense of what the individual is trying to convey. If the individual is trying to convey something very useful to you, then it's probably worth exploring a little bit more how the research was conducted. If it doesn't seem that useful to you, then basically you've gotten as much as you need to get out of it. So to put this in a very simplistic way, what this is saying is we're more likely to use a system if we're satisfied and we perceive it to be useful. If that comes as a shock to you, then it's worth studying this research. If that seems like something you'd accept without any research, then welcome to the world of academic research. So that concluded the slides that we covered in the Statistics Bootcamp. This should give you a general idea of the techniques you'd encounter during the program, or you have encountered if you're taking the boot camp as a refresher. And for those of you who do not attend the boot camp, these videos should hopefully give you enough information so you can get a sense of what the boot camp was. Naturally, if you have any questions, you can feel free to email me, Grandon at usf.edu, and I'll do my best to answer them. So thank you.